Hello everyone, in this lecture we will cover one of the fundamental algorithmic problem solving, which is exhaustive search. This is the outline for this presentation. We will discuss one by one. The first thing is algorithm analysis, then we will see brute force approach. One of the variations of brute force approach is exhaustive search. We will see the exhaustive search technique along with its limitations and applications. First of all, hope you all know the definition of algorithm. Let me explain with the real time example. If you are assigned with a task to draw a particular picture under a theme, what would you do? The first thing is you have to explore the theme to draw a picture, and then you have to set up with the necessary things used to draw. Start outlining the picture and then you will do coloring and texturing process. Throughout this process, you will do each and every task in a sequential manner. That is what about an algorithm. So, algorithm is a set of instructions which will be done in a sequential manner or in step by step manner with the intention of solving a given problem. For a single problem, we are having n number of algorithms to solve. Among these, we have to select the best one. How would you choose the best one? There are two performance metrics which are space complexity and then time complexity to select the best algorithm to solve the problem. So, space complexity is how much amount of space it requires to store the input variables, intermediate variables as well as output variables. And what about time complexity? Time complexity means how long the algorithm will take to complete the problem. Space complexity is not a big deal, so we must focus on the time complexity, that is how long the algorithm will take to complete the given problem. It is basically depending on two parameters. One is the basic operation of an algorithm and another one is how many times the basic operation will be executed. So, the main task of an algorithm is to convert the given input to the output. So, take an example to search an element n in the given list of array. So, given list of n numbers or 10 to 100 numbers, we have to find the given number in the array. So, what is the basic operation? We have to start from the first element of the array, whether the first element is equal to the given number n or not. So, the basic operation is comparison. How many times the comparison will be done up to the end of the array? That is, if the array size is 100, we have to start from the first element to the 100 elements. The execution time will depend on how many times the comparison operation, that is the basic operation, will be executed, and then for a single basic operation how much time it will take to solve the basic operation. So, one of the variations of brute force search is exhaustive search. Exhaustive search, it will be applicable for combinatorial objects. That means the problem will have the input types as permutations, combinations or subsets of a set. For these kind of problems, the brute force approach is known as exhaustive search. From the name itself, we could identify exhaustive search means totally exhausted. That means the problem will take more amount of time to produce the solution. The method of solving exhaustive search is outlined here. First thing is we have to generate all the possible or potential solutions. Among these, we have to identify the best solution. What do you mean by potential solution? Potential solution means possible solution. That means we are having a set of constraints. If the solution satisfies the constraint, then the solution will be known as potential or possible solution. For a kind of optimization problem, we have to identify the best solution. When will we stop the process? If the best solution is identified, we could stop the process. We will see some of the examples for exhaustive search. The first one is traveling salesman problem. I think you all know, some of you know the actual concept of traveling salesman problem. Here you have given it n number of cities with the known distance between each nodes, each city, and our main task is to identify the shortest tour path that covers all the cities only once before returning to the starting city. So here our objective is to minimize the tour path, and our constraint is to visit all the nodes only one time. So here it is the constraint and it is the objective. Okay. This is otherwise known as finding the shortest Hamiltonian circuit problem. So what about the execution time? So we are having n number of paths. N number of paths may be considered as permutation. So the formula is NPR n factorial divided by n minus r factorial. For this example, we are having 4 nodes. If you are starting from the source node A, it has to visit remaining 3 nodes. So the value for n is 3 and the r value is also 3. So substitute these values, we are getting 6 possible tour path. Among the 6, we have to identify the best one tour path. So the tour paths are listed here. First, we are starting from A to B, C, D, and then finally we have to return back to A. The next tour path is A to B, B to D, C, A. Next is A to C, B, D, A, and then A, C, D, B, A. Likewise, we are having 6 tour paths. For each tour paths, we have to identify the tour path cost by adding the H value, H weights. So for example, A, B, C, D, A is a tour path. Then the path value will be calculated as A to B is 2. Then B to C is 8, C to D is 1, D to A is 7. So add these values, 4 values, we are getting the total tour path. Likewise, we have to calculate the tour path for the remaining 6 paths. Finally, so these 6 values are known as potential values. Among this, which one is the best value? Here our objective is to minimize the tour path. So the value is 11 here. So we are having 2 paths, 2 shortest paths. One is ABDCA and another one is ACDBA. So these are the shortest tour path. The time complexity for solving traveling salesman problem using exhaustive search is omega of half n minus 1 factorial. N indicates number of nodes. Omega is the worst case time complexity. Okay. The next example is knapsack problem. Knapsack means we are having a bag. We have to hold n number of items to the bag with some constraints. Let's see the constraints. First thing is we are having n number of items with known weights and values. So each item has its own weight as well as the value of the item, and also we are having the knapsack of capacity, that is holding capacity of the bag is given as W. Our objective is to find the most valuable subset that fit into the knapsack. Here the objective function is to maximize the value, and the constraint is the weights of the items to be holded in the bag should be less than or equal to the capacity of the knapsack, so that the bag could hold the items. Let's see how to solve. So we have to derive the n number of objects for this problem and solve the problem. Finally, we could identify the best solution. Here the number of subsets will be calculated as 2 power n. N indicates the number of items. So 2 power 4, we are having 4 items. So 2 power 4 is equal to 16. Solutions to this problem. Among the 16, we have to identify whether it is feasible or infeasible, which means possible or impossible solutions. Finally, we could identify the best solution. So we are having the first item with its weight as 7 and value is 42. Remaining items are having weights and values with them. Our knapsack capacity is 10. That means the knapsack could hold the items with capacity less than or equal to 10 kg. Let's explore the 16 sets here. The first thing is the subset value as null. That means there is no items in the bag. So the weight is 0 and the value is 0. If you are taking the first item, the weight is 7 kg. That is the weight of the first item and value of the first item is listed here. If you are taking the second item, then the value is 3, 12. Likewise, 3 for the item 3, the weight is 4 and the value is 40. And for the fourth item, the weight is 5 kg and value is 24. Likewise, we have to explore the remaining subsets. If you are holding the items 1 and 2, then the weight is the sum of the two items, 7 plus 3, and the value is the sum of two items, 42 plus 12 is equal to 54. And if you are taking the item 1 and 3 in the bag, the value for the weight for the first item is 7, the weight for the second item is 4. So 7 plus 4 is equal to 11, which exceeds the knapsack weight. So we could not process it. Likewise, this solution is not also correct one. For the remaining subsets, we have to calculate the total value. We have to go through the total value in this column. Final solution is item number 3 and 4 will be taking into the knapsack, then its total weight is 65. Okay. So the time complexity for this knapsack algorithm using exhaustive search is big O of 2 power n. The next one is assignment problem. Here the problem statement is stated as we are having n number of problems and n number of people. We have to assign a person with a problem. The constraint is we have to assign a single job to the single person, and a single person will be assigned with a single job. And our objective is to minimize the total cost for solving the given problem by n number of people. Okay. This matrix is given in the question, that is we are having 4 person and 4 jobs. This matrix is known as assignment matrix. It can be interpreted as person 1 will expect 9 rupees for solving the problem and 2 rupees for solving the problem and 7 unit of amount for solving the problem and 8 amount of rupees for solving the problem D. Likewise, we can interpret the assignment matrix.
We have to list all the possible solutions. If person 1 is assigned with job A and person 2 is assigned with job B and person 3 is assigned with job C and person 4 is assigned with job D. What about the total cost? So 1 to A is 9 and 2 to B is 4, 3 to C is 1 and 4 to D is 4. So add 4 values, we are getting the total cost. Likewise, we have to change the combinations and we are listing all the possibilities, and then we have to identify which one has the minimum cost value.
So by go throwing all the values, I think this is the minimum value, that is this one has the minimum cost value. So we can conclude that person 1 is assigned with job B and person 2 is assigned with job A, person 3 is assigned with job C and person 4 is assigned with job D. Okay. And the total cost is 13. So the time complexity for this problem is n factorial. So, some of the outline for exhaustive searches, as I have already told, it should be only applicable for the problem which has limited number of subsets. That means, if we are having the small instances, then it would be possible to use exhaustive search technique. And there are some alternatives for this exhaustive search. One is we can use Euler's etiquettes and shortest path or minimum spanning tree concept. Okay. So, we have discussed what is algorithmic problem solving technique, and one of the fundamental algorithmic problem solving techniques is brute force approach, and its variation exhaustive search with 3 examples: traveling salesman, knapsack algorithm, and then assignment problem. Thank you.